Have you ever laid on your back on a lazy summer afternoon with a friend, seeing how many shapes you could spot in the clouds? Humans are particularly good at this sort of thing, seeing patterns, that is. In fact, we're so good at seeing patterns, we're too good. We sometimes see patterns that are not even there. Brain processing is based largely on pattern recognition. Probably has something to do with the fact that our brains are massive parallel processors, many neural networks or circuits in parallel, neurons connecting to many other neurons. We're therefore good at making connections between different ideas, visual patterns, words, events, and objects. We're good, for example, at metaphor, at representative and abstract thinking. Art is a good example of this, based upon the human talent for metaphor and making abstract connections. Thinking creatively, this is one of our strengths as cognitive beings. Additionally, we imbue meaning and emotion into those patterns that we see, into the abstract. So not only do we make connections, but we feel things about those connections. It has an emotional connection to us. It makes the patterns that we think we see seem real and meaningful to us. In fact, our brains are wired to do just that, to assign meaning and emotions to things. This pattern recognition is, however, filtered through a distinct part of the brain, or a different module, if you will, that undertakes what we call reality testing. It is like a filter. We see lots of apparent patterns in the world around us, and then we run those perceptions, those patterns, through a reality testing algorithm. Essentially, we ask the question, does it make sense? Which literally means, does it agree with our internal model of reality? We each have inside of our brains a model of how we think the world is and how we think the world works. And any new belief is tested against that internal model of reality. If it fits, then it feels right, it makes sense, and we accept it. If it conflicts with our model of reality, then we think, well, this doesn't make sense. It's probably not true, or at the very least, we will be suspicious of it. Interestingly, while we're dreaming, the reality testing module is turned down a little bit. It's not as active as when we are fully awake. This is why bizarre things can happen in your dream that your dreaming self accepts. It doesn't have the same reality testing filter that your waking self has. And then when you're awake and remembering the dream, it no longer makes sense to you, and you may puzzle over why you accepted such a thing while you were dreaming. There is a pathological condition known as psychosis, which is essentially a lack of reality testing, an decreased ability to test the patterns that we see against reality. This makes those patterns that we see seem far more real and compelling. Even very bizarre patterns can seem real and compelling to us, even if they require abject magical thinking, because the psychotic brain doesn't have as strong a reality testing filter in it. But let's get back to talking about the average functioning brain. There is a phenomenon known as pareidolia, which is a tendency to see a pattern in random noise. The cloud example I gave at the beginning of this example is probably just the most familiar example of this. We see either faces or animals or familiar objects in the random shape of the clouds. Nobody thinks that some force is actually sculpting the clouds to look like something. We recognize that it's completely random, but it still looks like something to us. Visual pareidolia is the most obvious example of the more general phenomenon of pareidolia. The brain seeks patterns to fit the stimuli. This gets back to what I discussed in previous lectures, that our experiences are constructed. And as our brain is constructing what we think we see and remember, it's also trying to make a pattern fit to patterns it's already familiar with. And we may experience this as a picture clicking into place when suddenly something is there. Previously, we were just seeing random noise, whether it's in the bark of a tree or in a stain or in a cloud, and then suddenly an image clicks into place. Our brain finds a similar enough pattern and makes the match, and then we see it. It's also interesting that once that happens, it's very difficult to impossible to unsee it. You now can no longer not see the pattern that your brain has clicked into place. There are many common examples of this. For example, there is a stain on a bank window in Florida that was there for a couple of years and nobody took any particular notice of it until somebody thought that the outline of the stain looked like the typical image of the Mother Mary. Once that suggestion was then published in the press and was put out there, then of course anyone looking at that goes, yes, I can see this pattern. It looks like an image of the Mother Mary. And of course, to believers, it was not just an image or a pattern. They imbued that with a very specific meaning. There is also another example, Medicine Hat, Canada. This is a natural geological formation that creates a very compelling image of a human face in profile. The face is not really there. It hasn't, as I said, been constructed in reality. It's constructed in your brain. You're filling in some of the gaps and the details, and your brain forces the fit to make it seem like a face to you. A lot of so-called ghost photographs are also based upon pareidolia. For example, you may be taking a picture of just a wispy cloud, or you may be bouncing a flash off of some dust in the room, and you get an overexposed cloudy image on the film. And our brains are very good at looking at the random noise of that cloudy photograph and seeing a face or the outline of a person. It's also very frequently reported that there is either Jesus or Mary sighting in this culture on a paint stain or a tortilla chip, a grilled cheese sandwich that was sold on eBay because of an image it was claimed of Jesus in the cheese, or on the bark of a tree. These have all been reported as apparitions of Jesus or Mary, when in fact they're just examples of pareidolia, the brain's tendency to see a pattern in random noise. The human face is also the most familiar pattern that we will tend to impose. It is the most familiar pattern to people. This has to do with the fact that we have a large portion of our visual cortex that is dedicated to seeing faces. It's obviously very important to us as social creatures to be able to recognize individuals very easily and very quickly. Infants prefer to look at a human face to other visual but equally complicated or interesting stimuli. And this means even from the earliest age that we can detect it, there seems to be this inborn preference for looking at the human face. We can, in fact, recognize tens of thousands of faces at a glance. Our brains are very good at noticing, remembering individuals. And this tendency, this preference for faces, this preference for the pattern of the human face, results in pareidolia, frequently resulting in a face. The face on Mars is one such example. When low-resolution pictures were taken by NASA probes, you see in this particular region of Mars, there's one particular formation that vaguely resembles a human face, especially when it's suggested to you. The face, however, is largely an illusion. Half of it is in shadow. One of the nostrils is actually just a missing pixel of data. It's not even real data in the image itself. It's a complete artifact of the picture. But our brain puts these details together and gives us the impression of a human face. A subsequent NASA mission took much more high-resolution pictures of the same structure, and that shows a normal geological formation. There doesn't appear to be any face whatsoever. The low-resolution face was completely an artifact of shadowing, etc. However, to those who are inclined to believe that there are alien artifacts, for example, on the face of Mars, like a researcher, Richard Hoagland, he believes that the face is real, despite the follow-up pictures that are higher resolution. He rationalized away these higher resolution pictures by saying that it was a conspiracy of NASA, that they doctored the photos, or perhaps they even dropped an atom bomb on the structure to destroy it before taking the higher resolution pictures. Patterns also have emotional meaning to us, as I said. We are especially good at inferring emotion from minimalist visual cues. We have a lot of hardwiring in our brain dedicated to doing this. We understand, for example, the emotion that a stick figure or a cartoon is supposed to have. And a skilled artist with just a few lines can convey an emotion, like make a stick figure seem angry or happy or scared, many different emotions. In fact, we can personify animals and cartoon characters and imbue them with the full range of human emotions, even again with these very minimalist cues. Emoticons are another fun example of this. In the computer age, and especially with texting and other forms of communicating with text, like emails, for example, people began to realize that it's difficult to convey the full emotion in just text. We rely heavily on nonverbal cues. When we look at somebody, we can tell by the inflection in their voice and by the expression on their face if they're being sincere or sarcastic, for example. You can't tell that when you're texting to somebody or sending them an email. So people use emoticons, which are little expressions comprised of keyboard characters, like a colon and a parentheses closure will equal a smiley face, and now you know that I'm making a joke rather than being serious. It's interesting that emoticons are different in different cultures. The emoticons that people in the West are familiar with are different than the emoticons used in Eastern cultures. Eastern cultures tend to pay more attention to the eyes when interpreting emotions, and research has borne this out. When asked to tell what emotion a picture of a person is displaying, they spend more time looking at the eyes, whereas Westerners spend more time looking at the mouth. This is reflected in emoticons, where Western emoticons tend to vary the mouth shape, whereas Eastern emoticons tend to vary the eyes in order to alter the emotion that is supposed to be represented. In addition to seeing patterns in visual stimuli, we can see patterns in other types of stimuli as well, like audio stimuli, so-called audio pareidolia. The brain has a limited number of phonemes, of components of spoken speech that it can distinguish. We mostly learn these by age 4, after which we tend to interpret anything that we are trying to understand as speech. We will tend to sort it into one of our learned phonemes. This is partially responsible for accents. People who learn one language may not be sensitive to phonemes that are not present in their language but present in a different language, and therefore they won't be able to make the proper distinctions when speaking that other language, and that will give them a recognizable accent. The brain tends to slot what it hears into one of the finite phonemes that are pretty much locked into place by age 4. It's not clear if there's a little bit of wiggle room in the future, but mostly our phonemes are locked into place. There is a phenomenon called electronic voice phenomenon, or EVP. Believers think that they are able to tap into the spirit world by listening to essentially static on tape recordings or some other recording device. What they do is they will listen through perhaps hours of recorded noise in an alleged haunted location, for example, and they will listen for words to pop out. Essentially what they're doing is a form of data mining, which I will talk about more. They're looking at large bits of data, looking for random patterns that will occur by chance alone. The random patterns they're sifting for are audio patterns. They're waiting for their brain to make a pattern fit to the random noise that is that they're hearing on the tape, and to fit it to some words. And then when they think they hear a phrase, the believers in EVP make the false assumption that the phrase is real, that some spirit or a ghost is actually saying those words, rather than what has been demonstrated psychologically, which is it's your brain that's making those words. Your brain is imposing those words onto that random pattern of noise. A similar phenomenon that is essentially the same thing, audio pareidolia, is so-called backward masking on music, or listening to music backwards for secret messages. This was popular for a while, especially in the era of tape-to-tape, deck-to-deck tape, when you could reverse the tape and listen to it backwards. It's harder to do that today with CDs and MP3 files. But back when you could do it with tape decks, you could listen to music backwards until it sounded like there were words being said in essentially the random noise of the backward music. Some groups and musicians did key into this phenomenon and actually deliberately put messages backwards in their music, but a lot of the time, and especially initially, it was just random noise in the backwards music that the brain fit to a familiar audio pattern. We also tend to be highly suggestible in this regard. For example, it's easier to hear what you're supposed to hear after you are told that that's what you're supposed to hear. And this has been documented experimentally as well. You can expose people to deliberately generated random noise generated as random, and then ask them if they hear anything. They may or may not recognize some words in the random noise. But if you say, now, this is what you're supposed to hear, and then you give them the speech, or you simply have the words that they're supposed to hear as text, then it's a lot easier. Then their brain will make the connection. It'll make the fit to the words. For example, a engineer has created a piano that is controlled by a computer, and by doing a rapid sequence of keystrokes, you can approximate human speech. In this way, the computer can speak through the piano. It's a little bit eerie, but it works very well. However, it's a lot easier to understand what the piano is saying when you have the text to read along with it. Your brain makes the match much more easily once it's suggested to you. An example of this that became a problem for a particular company was the Baby Cuddle and Coo doll. This doll makes essentially random cooing noises. Some people, however, thought that they heard the words "Islam is the light" or "Satan is king" in the cooing. Once that idea got out there, then people listening to the random cooing could hear the same phrases, "Islam is the light" or "Satan is the king." The doll eventually had to be pulled from the shelves for this accidental bit of audio pareidolia. I mentioned data mining earlier, sifting through large amounts of data looking for patterns. We are good at doing just that. This is a legitimate exercise, by the way, for generating hypotheses. When scientists have large amounts of data, they may literally mine the data using computer models or other algorithms to look for any apparent patterns. The problem, critical thinking-wise, that comes in is when you assume that the patterns you see are real, when you use the data mining as a way of confirming an idea rather than as just a way of generating hypotheses. It's okay to data mine when you're just generating a hypothesis, but then you need to confirm that the patterns are real by testing it against an independent set of data. That's another mistake that's commonly made, is to recognize a pattern through data mining, whether deliberate or inadvertent, and then to see if it holds up, but to include the original data in later analysis. But if the pattern was there by random chance, you're going to propagate forward that quirky random chance into future analysis. It's not a true independent verification. So an independent analysis has to use completely fresh data to avoid just picking up random patterns in the noise. This is most dangerous when it's done subconsciously, when data mining is subconscious, rather than a deliberately looking through stacks of data. That it's inadvertent because we don't realize that we're data mining, because we only tend to see the pattern. We don't see all the data that the pattern is buried in. This is sometimes called the lottery fallacy, just a tendency to think about things the wrong way. People might ask, for example, what are the odds that I would see a specific pattern, when they should be asking, what are the odds that I would see any pattern? This is like asking, what are the odds that John Smith would win the lottery? Well, it's hundreds of millions to 1 against. One might then assume that, well, it could not have happened at random then. It was hundreds of millions to 1 against. But that's because they're asking the wrong question. They should be asking, what are the odds of anyone winning the lottery? And it turns out it's pretty good. We do the same thing when we see a random coincidence. We ask, what are the odds that this coincidence would occur? Well, that might be very small. But what are the odds that any coincidence would occur is actually very high. In fact, it should happen on a regular basis. That's because that we're not aware of the fact that we are mining the potential data of all possible coincidences, and we're seeing only the patterns that emerge, the random coincidences. Astrological researchers famously fall into this trap all the time. They crunch through actuary tables, for example, looking for any pattern in the data related to an astrological sign. So they may conclude that Virgos are more dangerous drivers. They have more car accidents than other sun signs. But what they don't realize is that they were looking for any possible match, any outcome to any astrological sign. By odds alone, there's going to be random noise in that data. There's going to be some patterns that emerge. In order to know that that pattern is real, they would have to then verify it with a completely independent set of data. Of course, when that's done, it turns out that there is no consistent pattern with astrological signs. Astrology is based almost entirely on this false pattern recognition and data mining. Let me move on to another concept which is related to this, but that's also very important to understand in order to know how our brains work and how they can lead us astray. Psychologists now recognize a phenomenon called hyperactive agency detection. I spoke in a previous lecture about the concept of agency, that something is acting on its own will. There is a will behind what is occurring, what something is doing. And we tend to feel that something has agency when it acts as if it has agency. So when we see an animated robot, we emotionally react to that robot as if it were alive, even though we know it's a thing, because it's acting like something that has will. We tend to assume agency even when randomness is sufficient. So that's why it's hyperactive. We tend to err way on the side of feeling as if there's agency even when there isn't. One might take an evolutionary perspective to try to explain why it is. Why is it that we err so much on the side of assuming agency even when there probably isn't? Well, evolutionary explanations are difficult because it's very difficult to test them, but putting aside the question of whether evolutionary psychology has legitimacy as a science, it is interesting that it's easy to come up with adaptive explanations for why we may have this hyperactive agency detection. For example, if we are on the plains of Africa and we hear a rustling in the bushes, if we assume it's the wind, then we may be at risk for getting eaten by a tiger. If we assume it's a tiger and we run away, then we're probably more likely to survive and have offspring. So one way to look at it is that we evolved from those ancestors who had hyperactive agency detection because that was a survival strategy. We didn't evolve from those who went to investigate to see whether or not the rustling bushes actually was a predator or not. This hyperactive agency detection is actually reflected in our neuroanatomy and in the way that we process visual information. Visual information is separated into various streams, after it comes into the primary visual cortex, which just assigns an image to it. That's when we just see our raw visual data that then gets processed so that we have like strong edge detection and we recognize an object. We can see that it's three-dimensional. We have some sense of how far away it is. Basic things about just seeing something in our environment. But then that information needs to be assigned specific meaning by our brains. Our brains will then take that object and assign it a known object. So if we see a hammer, for example, a part of our brain will see all the details of the hammer, but then that information goes to another part of the visual cortex which says that's a hammer, which assigns a meaning to it. Then there's another layer of visual processing in which that's further specialized, in which we separate out those things which have agency from those things which do not have agency. For those things that do have agency, we assign emotional meaning to them. That visual stream connects to the emotional part of our brain, and then we feel something about that object that has agency. So when we see a rock, it goes to a non-emotional part of our visual processing, and we see that's a rock. If we see a person that we know, that goes to the agency part of our visual structures, and then we feel something about what we see. We take that for granted, but that is just built into how our brains are functioning. This is how we can see agency in non-living things, like cartoon characters, which we know are not living, but we respond to them as if they are. In other words, our brains do not decide whether or not something is alive and then assign emotion to things that are alive. It decides whether or not something is acting as if it's acting with will, has agency, and then it assigns emotional meaning to it as if it's an agent. Something else that we have a tendency to detect is called essence, that things have an essence which make them what they are. It's kind of a magical thinking that's built into our brains. Psychological research, for example, looked at how children respond to toys. When a child, how a child feels about a toy will depend upon whether or not they imbue that toy with essence. So for most toys, children understand that they're just things. They will happily accept an exact duplicate of that thing because they realize that it doesn't matter. However, if a child has a favorite toy, a toy that they have had for a long time and that they talk about and talk to and treat as if it's an actual person, a being, then if you ask the child, would it be okay to substitute that toy with an exact duplicate, they very emotionally refuse. They do not like that at all. So what's different? What's different about a favorite toy versus another toy? The difference is that the favorite toy is imbued with essence. They think there's something essential about that toy that would be missing if even an exact replica. Exact replica is not good enough. We can speculate again as to why that is. It would make sense that, for example, a parent would not accept an apparent exact replica or duplicate of their child, another child that looks just the same. They would want to have their own child, and that's very important. So we could, again, imagine that there would be an adaptive advantage to having this sense of individuality and essence. Problems can arise, however, when we see agency where it does not exist. So not only do we see agency in how individual objects behave, but we may also see agency collectively behind events. We may see a quote-unquote invisible hand controlling events. This leads to conspiracy thinking. When we see a pattern, so this is now we're going to tie in pattern recognition and agency detection. We see a pattern in events that we think, all right, can't be a coincidence. These separate things could not have all happened by coincidence alone. The pattern seems too compelling because we're making the lottery fallacy and we're underestimating how often such patterns should emerge by chance alone. Then we further assume that if there's a pattern, there must be an agent behind that pattern. There must be a conspiracy. There is some organization or some power or perhaps even we might get into magical thinking, and we might think that there is some magical agent at work or some force of nature that is making things happen the way they are, because otherwise we wouldn't see this pattern. The ability to see patterns, even abstract patterns, is one of the human brain's greatest strengths. It gives us a lot of our creativity. It gives us a lot of our ability to problem solve, the ability to see the commonality among different things. But it's also potentially one of our greatest weaknesses. Again, as we see over and over again in this course, our brain's abilities are often a double-edged sword. They are great strengths, but also the source of great flaws if we're not aware that that's how our brains work. So we need to filter this hyperactive pattern recognition and agency detection through some kind of reality testing filter. We all have that reality testing filter in us to some degree, but that's not quite enough. It's critical to understand that pattern recognition, agency detection, belief in essence, the tendency to imbue meaning onto objects and to events and to things, data mining, all conspire together to create the powerful illusion that we are seeing something real in the world, even when we are not seeing something real in the world, even when it's just random noise. But the illusion is emotionally very compelling to us. It's very gripping. It screams for our attention. And it takes a lot of critical thinking skills and discipline to step back and say, wait a minute, is this real? Is this really real? And maybe even my intuition, my internal reality testing isn't enough. I need to systematically test these apparent patterns in some rigorous way to really know if it's real or not. We recognize illusory patterns all the time. Pareidolia, data mining, hyperactive agency detection, and superstitious thinking are all manifestations of it. But that is not all. There is something quite similar in our overall sense of self and in our sense of reality. We have a sense of what we think is real. But again, I will conclude with the good news, is that critical thinking skills are a way of sifting through all of this noise, transcending above our evolved tendency to over-detect patterns in agency, and to sort out what's really real from what only appears to be real.